Welcome back guys again for the next video, that is applications of Pascal's law. There are two applications of Pascal's law. The first one is hydraulic lift and the second one is hydraulic brakes. Both works on the same principle and they both holds the same formula. Okay, only the architecture or the construction is bit different, otherwise the concept is same. Okay, so what we have here is there are two containers which are filled with a fluid. Okay, we call it as a incompressible fluid. The smaller container is fitted with the smaller piston, okay, which has a smaller area A1, while the larger piston has the area A2. So here we have A2 is very much greater than A1. Okay, so the force F1 is applied on this piston in downward direction, which is called as a input piston. Okay, and this one is called as a output piston. So it exerts a force in upward direction to lift the vehicle placed on it. So the pressure generated at the smaller piston due to the downward force F1 is given by simply the formula for the pressure, P is equals to F upon A. In this case, P1 is equals to F1 upon A1. Similar formula can be written for the another container having pressure P2, and it is given by P2 is equals to F2 upon A2. Only the difference is F1 is in downward direction and it is smaller, and F2 is in upward direction and it is a larger. Why it is larger and why F1 is smaller, we will discuss that later. Okay, so we have the two pressure formula, P1 is equals to F1 upon A1 and P2 is equals to F2 upon A2. Now we can see here these two containers are connected by some means, or let's say by pi. That means the pressure created at this point is equal to the pressure created at this container, because according to Pascal's law, for the enclosed fluid which is at rest, the pressure applied at one point is equal and undiminished to the every part of a fluid. So pressure applied at this point is equal to the pressure applied to this point. That means pressure in container P1 in this container is equal to the pressure in the second container. So what we have is P1 is equals to P2. As P1 is equals to P2, we can write F1 upon A1 is equals to F2 upon A2. Rearranging this formula for the F2, we can write F2 is equals to A2 upon A1 into F1. Now we know that A2 is very much greater than A1. Okay, as A2 is very much greater than A1, therefore F2 is very much greater than F1. Because A2 is greater, so F1 is smaller, so therefore the numerator value, that is F2, will be larger than F1. So this is the explanation for the hydraulic lift and the brakes, which based on the Pascal's law. Only the difference is that in case of a brakes, the only brake pedal is one where the force is applied, that is the input piston. As here there are only one container, but in case of a hydraulic brakes, there are four containers or cylinder which are fitted to the different disc of the four wheels for the four-wheel drive, or the four-wheel based vehicle, and therefore when you apply force on the paddle, okay, that is the brake pedal, it will exert larger force and the vehicle may stop suddenly. Okay, so these are the two applications of Pascal's law. The first one is hydraulic lift and second one is hydraulic brakes.